Let me record this. All right. Welcome to STAT243. I'm so excited to be here. Uh, so my name is Melissa Kleiss. This is I think I started, yeah, so this has got to be year eight at RCC. So I just finished 7 years. This is my 8th year. I love it. I love teaching stats, especially. When I first started teaching it, I didn't like it because it wasn't mathy enough. But I really love teaching this class. It is a lot of fun. You will not notice that it's a lot of fun the first week. Unfortunately, all of the boring stuff is in chapter one. It's all that vocabulary and all of that because teaching stats and probability, it's like a new language. It's all going to be all new words. So today is super, super vocabulary heavy. So if you leave class tonight saying, man, that class is so boring, I am going to be boring tonight, but it gets better. And I love, 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 love what I do. And I'm super quirky and weird and it odd at times and, very human. So just keep that in mind. And I'll do the best I can to teach this class the way I would want to be taught. And I just welcome. We're going to have a good time. So today's objectives, we're going to look at chapter one. And we're going to talk about it's basically vocabulary. We're going to talk about quantitative and qualitative variables, discrete and continuous. We're going to talk about something called levels of measurement, and I'm going to tell you how I remember them, the little triggers that I use to remember them, because some of this stuff is hard to remember. So I'll try to tell you mnemonic devices and things that I use. Okay, hold on a second here. I've got something weird on my other computer. There we go. Okay, and then we're going to just begin section 2.1. We're just going to dive into it a little bit. We're not going to fully finish 2.1, but we're going to talk about putting qualitative data into tables, and we're going to talk about bar graphs. So that's as far as we're going to get tonight. At the very end, I'm going to tell you the type of data you're going to need to collect for the first lab. Next on Thursday, our next meeting, I will go over teach you how to do the first lab. I'll walk you through it. So if you want to collect your data ahead of time, that is not a bad idea. That way, maybe you can walk through it with me. I try to hide this bar up here at the top. Give me a second here. Okay. There we go. Beautiful. Much better. I know it doesn't affect your vision at all, but it affects mine. All right. So let's jump right into our vocabulary. So you hear the word statistics pretty much to talk about anything to do with numbers, but it actually it's a science for collecting, organizing, summarizing, and all of that with data. We use the statistics to draw conclusions. I am not going to be this particular vocabulary. I'm not going to test you on. If something is you're going to be tested on, or if it's something I really think you need to remember, I'm going to tell you to star it. And that way this is something you're going to be tested on. I try not to trick you. I generally am not somebody who tricks people on their tests or anything. I really try not to do that. I highly recommend printing off the PowerPoints ahead of time, ahead of class, because printing them off, you can take the notes directly on them. Then I allow you to use those notes on the test. Any paper notes that you generate, you can use on the test. So if you print off the PowerPoints and take your notes on the PowerPoints, you're going to be able to use those on a test. So I highly recommend printing them off. If you need to print them, I say 2 or 3 of them to a page. That way you're not using 5,000 pieces of paper. Like this one slideshow has 35. You don't want to print 35 sheets of paper. So print them front and back, print them 2 or 3 to a page, and it'll look really nice. And you can just write directly on it. Okay. So I use the word data and data interchangeably. It's the same word. I say sometimes in the same sentence, I'll call it data and data, and I hope it doesn't annoy you. It's just me. I'm quirky. It's what I do. Data is also plural, and it kind of annoys me because you'd say data are rather than data is. And I won't always do that because that also is weird. So data is just basically any of the information that you collect, the information that you collect to use to draw your conclusions. Sometimes it's numerical, like height or weight or age or something like that. Sometimes it's non-numerical, like species of pet or gender or right or left-handed, things like that. So it can be any kind of information that is a characteristic of whatever it is that you're studying. So what we're trying to do here is we're trying to use the data to offset anecdotal claims. So we want to say, like, prove something is true, prove a point. We're going to try to take a look if it's being misused by individuals, things like that. So I'm really hope that you guys get some great stuff out of this class because I've used the material so much in so many different ways. I'm always pulling out my calculator and calculating the probability of something really quickly, and it's loads of fun. All right. Oh, I also want to say that if you have a question, just interrupt me. Feel free to type it in the chat if you want, or just unmute and interrupt me. I'm not going to get mad. Okay.
Hey, Miss Kleiss, I'm sorry. I just joined the meeting because I was in another Zoom meeting introduction.
Welcome. It's good to have
Thank
you.
you.
We didn't get very far. We're only on basically the second slide, so you're good.
Okay, thank you.
No problem. All right. So a population. Now, the homework will have some questions about this. Just letting you know. There will be some questions on the homework. And I'm glitching out on you. Is anyone else having the same problem? It's glitching? No.
Yeah, it's not that you're glitching. You're not like freezing. Well, your voice is like going, like it's carrying on and it's just really choppy.
Oh, no. Okay. I don't know what to do. I don't know how to fix that. Okay. I don't know how to fix it. Okay, so yeah, I don't know I was trying to see if something's like updating or something or what's going on here.
That's great. It's not every time. It's like maybe once every minute, just a little bit. So I don't know if it's that.
Okay, we're gonna just blame Zoom on that, okay? We'll just blame Zoom. It's their fault. Okay, so the population is the entire group you're studying. So if you were doing a study at RCC to determine if there's a correlation between how much time they study and the grade they received, your population would be all RCC students. So even though you are not going to sample to poll every single RCC student, that's what we're studying. We're studying the student body of RCC. So that would be your population. So the sample would be the subset. So the sample are the people you actually talk to. So if I polled 50 RCC students to find out how long they study and what their grades are, that would be my sample. And I'm going to use the data that I get from the sample to apply it to the whole population. Sorry about my cat. Clementine she's a big pain right now. Sorry about that. She's in heat. She's just a baby, but yeah, she's sorry. Okay. So the individual would be one person you talk to, one individual student at RCC. So every student is an individual, and then all of those individuals that I speak to are the sample, and then I'm using that sample to study the entire RCC population. So whatever data I gather, I'm going to apply it to that entire population. All right. All right. So this, I usually, when I'm in, I'm going to preface this, when I'm in an in-person class, generally what I do on the first day is I hand everybody a Post-it note. And so this would be anonymous. And I would give this scenario. I would say you're walking down the street and notice that a person walking in front of you drops $100. Nobody notices the $100 except for you. You could keep the money and nobody would know that you kept this money and you would just have $100 and nobody would know, or you can return it to the owner. So I always ask this, and then I ask them to anonymously write down whether or not they would return the money. So usually I only have one or two people in class that'll say they'll keep the money. Actually, in high school, the number is a lot higher, people who would keep the money, than in college. And maybe I don't, yeah, I mean, I can't speculate as to why that is. I can have ideas in my head, but I'm not going to speculate. All right. So we're going to pretend that I polled our class of 30 students and that 28 out of 30 28 out of 30 said that they were going to return they would return the money. That is basically 93.3%. I'm just going to say 93% because that line is really small and I can't write 93.3 on it. So this class is a sample of the entire RCC student body. Therefore, this is a statistic. So a statistic is a numerical summary of a sample. Think statistic starts with S, sample starts with S. When we're talking about a statistic, we're talking about something to do with a sample. So descriptive statistics is when we're describing our sample data through whatever kind of summaries we're doing. So if I'm like, for example, right here, me saying 93% of our class would return the money to the owner. Or if I put my data into a table or a graph or something, but I didn't make any conclusions, I'm just describing what I observed. That's descriptive statistics. You will have questions on your homework about whether it's a statistic or a parameter. Give me a minute, we'll get to parameters. Right. Also, feel free to holler at me to slow down if I need to, if I move too fast. Sometimes I get excited and I move too fast. Okay, so I said, what was it? What was the number? 28 out of 30. That was 93%. Woo. Okay, so inferential statistics is when if I took the sample and I extended it to the entire population. So if I said that 93% of our class would return the money to the owner, therefore, I believe that this can apply to all of RCC students. So I would have to include a margin of error. Don't worry, we're gonna later on down the line, I'll tell you how to calculate a margin of error. But I could say between 92%, okay, I could say with 95% accuracy, actually, I'm going to say between 90% and 96% of all RCC students would return the money. Now I'm saying that based on my data, I'm going to apply this to all of RCC. I'm inferring that this would apply to all RCC. So it's inferential statistics. So I'm extending it to the population. And I just, in my brain, magically made up this 3% margin of error. And you've seen this in, I'm sure, presidential polls and things like that, where it'd say this candidate has 46% of the vote, plus or minus 3% when they're taking polls. That's what we're doing with the margin of error. That's a few weeks down the road. But that's essentially what this is saying. My 3% margin of error is saying that 90 to 90%, 96% of all RCC students would return the money. So this is inferential statistics. All right. Let's move on to parameters. Suppose the percentage of all students on campus who have a job is 84.9%. So I actually was able to go to every single student, or maybe there's something in the computer system, and determine how many of all of them have a job. I take a sample of 250 students, and from that sample, 86.4% have a job. So these represent the sample. So here, this is right here what you want. This is your gold. This is what's going to help you on your homework. So a statistic is a numerical summary of a sample. Parameter is a numerical summary of a population. So think statistic, sample, they both start with S. Parameter, population, they both start with P. I love that they did that. Makes me really happy that they have that alliteration there so that I don't have to think of a different mnemonic device. So the alliteration is nice. So you will need this on your homework. So the goal of inferential statistics, we're trying to use the samples to estimate the parameters. We want to take our samples to estimate our population, because most cases it doesn't make sense, or it wouldn't be like financially feasible to or just like to poll everybody. It would be really hard to poll everybody in the United States. I mean, we do that every 10 years for the census. It's a big job. So it's really nice when we can get a nice, good statistic to estimate a parameter. I'm going to give you a second to write that down, and then we will move on. Oh, and what I forgot to tell you all, and I know I said this in my email, but I will never go all the way to 750. Never, ever, ever. I don't want to listen to myself talk for 2.5 hours. I don't think y'all want to listen to me talk for 2.5 hours. So I will never go to 750. So it's usually I'm done by 6:30 or 7. Occasionally, if there's a lot of questions, it'll go slightly past 7, but 7:50, it's never going to happen. Never ever. So just wanted to throw that out there. I don't do breaks because I don't talk that long. I usually only go for an hour. So hour, maybe an hour and a half, so I don't give breaks. If you're more than welcome to get up and, go whatever you need to. If the class feels that I need to start giving breaks in the middle, if y'all decide that that's what we need to do, we will talk about it. I'm not against having breaks. I just, I've had most of the time people don't feel like they need it. See, my bedtime's also about 8. I agree. I don't want to stay up that late either. So usually I try to get done talking within about an hour, hour and a half max. Because we all don't want to hear me talking for that long. Okay. So I am never going to ask you to give me back this process of statistics. I'm just wanting to show it to you. Anybody who is sciencey will see that the process of statistics and the scientific method are really similar. And so I'm kind of making that connection here. But you're not going to have to reiterate this to me. You're not going to have to go through this and tell me all these steps of statistics. So the first thing you need to do is figure out what you want to know. What question are you trying to answer? Before you even take any data, before you ask people questions, what are you trying to learn? Are you trying to figure out how much caffeine people consume on a daily basis and if it affects their sleep? Are you trying to figure out if starting school, high school later, results in better performance of students? You need to figure out what is the objective? What do you want to study? The next thing you want to do is you need to collect your data. So figure out what data you need in order to answer your question and go and collect it. Now you're not drawing any conclusions, you're not doing any of that. And if you have to make sure you collect the data correctly. So you want to use random samples. You don't want to put a poll on Fox News to ask a question about whether the Republicans are doing a good job, because Fox News generally leans right. You're only going to get the Republicans or the people leaning right answering the poll. Just like you don't want to go to MSNBC and ask if they think President Biden is doing a good job, because that MSNBC tends to be a little more liberal, and you're going to have the people a little more liberal answering the questions. So you need to be really careful answering your questions in order to get a really good, true sample. So after you collect your data, then you're going to describe your data. This is where we start to put it together and count things and say, okay, so it's 93% of my class answered this question, yes. This is where you're not actually doing the analysis yet. You're just kind of prettying it up. You might be putting it in a graph or a table or something. So you're trying to pretty it up a little bit. Oh, I forgot to read this little, you can see this. The samples I was telling you about, those internet polls on like MSNBC or Fox News, those are called convenience samples. And they are not very good, accurate measures of like what the population is. They're not very reliable. Random samples are the best. Okay. So after you describe your data with graphs and tables and things like that, number 4 is where you're going to math it out. Whatever techniques that you learn in this class, or if you go to further statistics classes, 244 is after this one. I highly recommend it. It is fun. There's lots of good stuff there. Anyway, you're going to use your analysis methods. You're going to use the math that we learn in this class to analyze your data. And then that's going to help you to perform your inferences. That's going to help you to say, I think that between 90 and 96% of all people, or all RCC students, are going to return the money if they see it. So this is where you do the math and you can perform your inferences. This is where you get your lovely conclusion. Finally, oh, so part of 4 is writing a conclusion. Usually we write something nice and pretty. I'm not going to be a super stickler about you writing something pretty, and I'm going to tell you the trigger words I want you to put in your responses. Once again, I'm not into tricking you. I want to make sure that you actually are getting out of this what you need to get out of this and giving me back what I give you, what I teach you, rather than trying to be super tricky. Okay, so here's an example. We're going to pick out all the pieces. So I need to get a different, better example because the word batterer is hard to say and it's kind of annoying. But anyway, so there's a lot of studies that evaluate batterer treatment programs. So this experiment that we're going to do here, or that we talk about here, is going to see whether or not a batterer treatment program is going to be better than a non-therapeutic treatment, such as community service. So these researchers, they took 376 male criminal court defendants who were accused of assaulting their intimate female partners. So it could be a girlfriend, could be a wife, whatever. They were randomly assigned into either a treatment group or a control group. So the treatment group went into a 40-hour batterer treatment program. The control group did 40 hours of community service. After 6 months, they evaluated it again. 21% of the males in the control group had further battering incidents, while 10% in the treatment program had further battering incidents. So the researchers, based on this, they concluded that the treatment was effective in reducing repeated battering offenses. All right, so now we're gonna break this down. The first step was to determine what question are we trying to answer. So here we are. The question that we were trying to answer was whether or not the batterer treatment program was more effective than the 40-hour community service. So we haven't taken any data yet. We're just figuring out what is our research objective. So they're trying to push for these batterer treatment programs, saying they're effective. So they're trying to show that they are. Number 2, collect your data. The way that they collected their data was they split them into 2 groups, and they had half of them in the 40-hour batterer treatment program, half of them in community service. Then after 6 months, they looked at how many reoffended. So this was how they collected their data. Thankfully, our data is going to be a little bit easier in this class to collect. You're not going to have to wait weeks or months or whatever to recollect, but this kind of gives you an idea of this particular study. So describing the data, organizing and summarizing. Okay, so after the 6 months, 21% of the males in the control group had further incidents, 10% and then in the battering treatment program, only 10% did. So there's not a whole lot more math to do here. So, but this to me, this looks pretty clear. You can see the nice data that they have there. Finally, our conclusions. So we can extend these results. We take these results and we extend it to the population. So we are saying that males who batter their female partners and participate in batterer treatment programs are less likely to batter again. One thing you need to notice here is that all of my participants were males who battered an intimate female partner. So on my conclusion, I can't just say people who batter their partner are less likely to batter again. We don't know if this works for females who batter their male partners. We don't know if this works for same-sex couples. All we know is that this worked for males who battered their intimate female partners. So you need to be really careful with who you are saying your population is. Your population and your samples need to look the same. Any questions on this?
How big of a sample size do you need to have to be able to apply it to a population?
That's a really great question, and you're going to hate my answer. It depends. We will have a formula later on in the term that we can use to determine what sample size we need based on the study we're doing. So, for example, if I wanted to have a smaller margin of error, I'm going to have a bigger sample. If I want to be, because I said, remember back on the when I was looking at samples and the statistics, sorry, with the dropping the $100, I said we're 95% sure that that this many students would return the money. So if I wanted to be 99% sure, I'm going to have a bigger population or bigger sample. So there's a few factors in play, and I'm going to show you the math on how to figure that out. So that was a really great question, though. Thank you. Sorry, I was less than satisfying answers, but wait, it'll be great once we get there. Okay, more vocabulary. Don't we just love vocabulary? Okay, so variable, and variable basically means the same thing that it means in any other algebra class. It's just the variable is going to look different. It might not be just a number. So variables are just characteristics of an individual in a population. So it could be things like hair color. That would be a variable. It could be how many baskets you made when you're shooting free throws. It could be how tall you are. Um, Variables vary. If all variables were exactly the same, we wouldn't need to do any statistics and it would be really boring. Everybody was the same height or um, everybody was the same age. Yeah, so variables vary. That's really what it is. So these things, you're going to be asked if things are qualitative or quantitative. So this is something you will be asked. I think it might even be on the test. I can't remember. Qualitative is also called categorical. These two words are interchangeable. Think qualitative qualities. So that's how I remember it, is thinking qualities rather than quantities. So qualitative and categorical are the same thing. They are classifying individuals based on some attribute or characteristic, generally not numerical. And if it is numerical, it's something you're not going to do math with. So hair color, right or left-handed, male or female, your gender, as I just said that. It could be how many or what type of pets you own. So it wouldn't be how many, but it would be what type of pets: cats, dogs, lizards, bluebirds, whatever. Birth date, we don't always do math with birth date, unless you're asking somebody like, how old are you, like age, or how many years apart are you? But generally, it's like I say my birthday is in April. That'd be a category. Gender, zip code. Zip code. I don't think I've ever done math with a zip code. So zip code would be more qualitative or categorical. So quantitative are numbers that you can do math with. So think quantity, quantitative, quantity. That's numbers you can do math with. So temperature, number of days a student has studied, height, weight, how much caffeine you had, things like that. That would be quantitative. So qualitative is non-numerical or numbers you don't do math with. Quantitative is numbers you do math with. So we're going to do a couple examples here. I have cat hair on my iPad. So this researcher, Elizabeth Kavavic, and some others, they studied the effect of eating habits on adults in their mid-30s. So they looked at different variables here. So we have our first, we're going to classify these as quantitative or qualitative. So first, nationality. So nationality is not a number. You wouldn't do math with it. So this would be qualitative. It is a quality, not a quantity. Number of children. So I could say I have 2 more children than that person over there. I can do math with the number of children that I have or that people have. So this would be quantitative. Excuse my bad handwriting. You're going to get used to it. Household income the previous year. We all do math with money. All of us every day are doing math with money. Obviously, this is quantitative. Now, level of education could be tricky. So level of education thinking, something like associates, bachelors, masters, that is clearly qualitative. But if you're thinking like first grade, second grade, third grade, that kid is 2 grades higher than the other. But I generally, with level of education, would go qualitative because we're all in college here. We're thinking associates, bachelor's, master's, PhD. So that level would be qualitative. So it really depends on whether you're saying that they're 2 grades higher than the other one. It depends on what you're doing, what you're using it for. So sometimes you just have to make a judgment call based on how you're using it. Daily intake of whole grains measured in grams per day. I ate 2 granola bars, so I had twice as much intake of whole grains as the person who ate 1 granola bar. That's definitely quantitative. Oh, my iPad like glitched. That's really ugly writing. All right. Questions on qualitative versus quantitative. And just remember that qualitative could also be categorical. I'm just going to write it once, but I usually say categorical. I like the word better. But it's the same thing. It is, they're interchangeable. I'm not sure what my old math uses. I haven't checked lately and I can't remember. Okay, moving on. All right. So now we're going to jump to discrete versus continuous. Once again, this is, I believe these will definitely show up on your homework. It might show up on the test, but definitely going to show up on your homework. So discrete variables, both discrete and continuous are quantitative. So we're going to stick the qualitative in your pocket. We're not going to look at those for a little bit. So qualitative, just stick them in your pocket and don't think about them for a moment. So discrete and continuous are quantitative variables. They're two different kinds. Discrete variables have a finite number of possible values. If I graphed them, I would have to lift my pencil for the dots. So for example, it would be like this. So this would be a discrete variable because it doesn't take on every value, doesn't take on every possible value. So it's usually something that's countable, like number of students in class, how many TVs sold last week, number of red marbles in a jar, um, how many days of paid time off do you have? How many days until summer vacation? Things like that. Those are discrete variables. They're something countable. How many kids do you have? They're countable. Continuous variables, on the other hand, are things that aren't countable. They're things that can take off on an infinite number of possible values. If I was to graph it, it would be a smooth continuous line. I can draw a continuous variable without lifting my pencil. So if like height, I'm 5'2". I had to be 5'1 3/4" before I could hit 5'2". If something weighs 85 pounds, it had to hit every other weight up until there before it hit 85 pounds. Distance that you traveled. I can't travel 30 miles without first traveling 29.5 miles. Same thing with temperature. It's got to hit, if it's 40 degrees in the morning and 60 degrees in the afternoon, it had to hit every other temperature before it hit 60 degrees. So that would be continuous. Discrete is something countable. Continuous is something that can take on an infinite number of values. Questions? Okay. Can you just give you a second? More like a figurative second, not a literal second. Let's jump here to Elizabeth Kavavic again. So these are 3 variables, and we're going to talk about if they're discrete or continuous. Number of children. This would definitely be discrete because it is something countable.
But doesn't it have to hit like every mark before then? I don't know why it's not Is it because it's such a low number?
Well, it's because I can count them because there's something countable. I'm not going to have 2.85 kids before I have three kids.
Okay.
And
Okay.
kind of you're kind of splitting hairs like with pregnancy and all that, but I'm not going to have 2.58 kids. If I go to your house and count your kids, I'm going to be able to count them with whole numbers.
Okay. That makes more sense. Thank you.
Okay, household income the previous year. Now, this one, some people say you can't, it's going to be down to pennies and you're not going to have partial pennies. But if I make $50,000, I had to make $49,999 before I hit 50,000. So it does have to hit everything all through there. Generally, with finances like this, we just call it continuous because it does have to grow. Continuous. Okay. See, once again, I don't really like the whole grains here, but thinking about it, if I'm eating off of like granola bar or I'm eating some quinoa or I'm eating something, it has to take on every value. Even though I'm eating a spoonful, it's not something that's going to be countable. My first bite of a granola bar is not necessarily going to be the same size as my second bite of the granola bar. You're not going to count grams like 1, 2, 3, 4, 5. It's going to be a continuous thing if that makes sense. And I'm going to try to make sure that I give you, um, if you guys didn't tell me I spelled words wrong. I'm generally a good speller. There we go. There we go. That's better. All right. Make sure you correct me if I do something weird. All right. So that would be continuous. So discrete, I really love to say that it's just whole numbers, but I'm going to give you an example that kind of goes against that, but I'm hoping it'll make sense to you. Let's say that we're doing a fundraiser and I'm selling t-shirts for $7.50 each. Weird amount, I know. But I'm going to have, here's my lovely graph. I sold one t-shirt. Have $7.50. I'm going to sell a second t-shirt. I'm going to have $15. I didn't have to have all the money in between that because one shirt is $7.50. And then when I sell a third shirt, I'm going to have $22.50. So this technically would still be discrete because it's jumping by a regular increment. It's, every time I sell a shirt, it jumps by 750. I'm never going to have 13.75, $13.75. I'm going to go from 750 to $15. So it doesn't necessarily need to be whole numbers, but usually it is. But if I'm never going to have any values in between there, then in between those two values, then this is discrete. Did that help at all with the children thing? Okay.
Yes, it really did.
Okay, good. It's like racking my brain trying to figure out how to help with that. All right. Now, before we do levels of measurement, I'm going to stop this and give you a good little side thing here. Levels of measurement can be kind of confusing. Um, I'm going to do my best to give you exactly what I use in my brain to remember these. And yeah, so there's little tricks to remember these because this is a lot. And if you printed out the PowerPoint, I would recommend writing down my little tricks to remember these. So I'm going to tell you what those are. Hopefully it'll help. So starting at the top, these two right here are categorical. Those two right there are categorical. So if you have numbers you can do math with, ignore the first two. So these two are just categorical. So the nominal level of measurement, order doesn't matter. This is how I remember it. Order doesn't matter. So this would include things like gender. It doesn't matter if you say male and female and non-binary in that order. It doesn't matter if you say female and male. It doesn't matter what order you do this. Same thing with left-handed, right-handed. Same thing if I was listing religion or favorite color, or anything like that. Or, the colors of the cars on my street. It doesn't matter which order I list them in. M&Ms coming out of a bag of M&Ms. It doesn't matter. Order doesn't matter. So that's the examples here: gender, handedness, religion, favorite color. Order doesn't matter. They're just a pocket full of categorical data that doesn't matter what order you put them in. So ordinal, order matters. I love that the word order is kind of right in the word. That's kind of cool about it. Order matters with ordinal. So you're going to look at your grades. If your letter grades, you have A, B, C, D, F. Those are letter grades. Order matters. It would be really annoying if I said put the grades in a weird order and said something like D, B, C, A, F, like something like that. Order matters. Um, I say satisfaction. So we've seen those satisfaction ratings where they say like highly dissatisfied, dissatisfied, neither satisfied nor dissatisfied, satisfied, you know, um, highly satisfied. You're going to have an order of those. Or think about associate's degree, bachelor's degree, master's degree. So level of education, starting elementary school, middle school, high school, and all of that. So order matters. So ordinal level, it would be things that order matters, and nominal is if order doesn't matter. Questions on the categorical ones? Okay. The other two are where we get a little bit more confusing, but I'm going to do the best I can. These are quantitative. These are the quantitative ones. So interval level of measurement. So these are quantitative, as I said. Here's a couple of the things that are going to help you. A value of 0 doesn't mean absence of quantity. And the math you are most likely to do with it is addition and subtraction. These are the two things that you're going to look at when you're determining the level of measurement with a quantitative variable. So thinking about temperature, a temperature of 0 degrees doesn't mean that there's no temperature. It just means it's really cold. So it doesn't mean that it doesn't exist if it's at 0. That's what I mean by it doesn't mean an absence of quantity. A temperature of 0 still has meaning. Calendar years. If there was a year 0, which there wasn't, but if there was a year 0, it doesn't mean that nothing happened before that. It means that that's like the beginning of our common era. So elevation, same thing. 0 is just sea level. We can go below sea level and you can go above sea level. 0 is not an absence of value. The whole addition and subtraction thing, I don't usually say that it is twice as hot today as it was yesterday. You would say it's 3 degrees hotter today than it was yesterday. We don't usually use multiplication and division with temperature or elevation. You would just say, it's 50 feet higher in elevation than the other mountain. I don't know. So generally we would use addition and subtraction here. But the 0 being an absence of quantity, that's your gold standard. Okay. Ratio level of measurement. With ratio, a value of 0 does mean absence of quantity. So when you look at the 0, it means that it's not there if you're with the ratio measurement. Also, the math that we're doing with it, we can do multiplication and division with it. So money in your pocket. If you have 0 money in your pocket, there's nothing in your pocket except lint. There's no money if it's 0 money. And I can say that I have twice as much money in my pocket as somebody else. Makes sense. If there's 0 height, that thing doesn't exist. If they aren't tall, they don't exist. If they're at zero height, that doesn't even make sense. Something can be twice as tall as something else or half as tall as something else. Same thing with weight or time you spent watching TV. If I didn't spend any time watching TV, there's no quantity there. I spent twice as much time watching TV on Sunday than I did on Monday. That makes sense. I can do multiplication and division there. I'm going to give you all a moment to write this down because this is a lot. Um, Questions on levels of measurement. And star, there will be questions of levels of measurement on the first test. 100% count on it. I will give you a scenario or a variable, and you will tell me what level of measurement it is. So yes. Questions, comments, queries, concerns?
Will we be able to use this slide on the test like all the others?
Yes, as long as you print it off. As long as you've printed it off and you're taking notes on your slides, then those are notes you've generated. I call that a loophole.
Okay, thank you. And there's like nothing that I can't not write on here. Like, is there something that I shouldn't write down that you say
Right,
to
whatever,
use, or does it all work?
write whatever you want. I'm not gonna, you're gonna be taking the test online. I can't see what you've written on it anyway, so you're good.
Okay. And I took Respondus in the past. I just didn't know like if it would think I was cheating if I looked at a paper. So does that all work fine?
Okay, so what happens is Respondus, I don't like sit there and watch the whole thing. That would be ridiculous. But Respondus, what it does is it will give me an alert. It'll tell me if something weird has happened, and it gives you different levels of alert. So it'll be like a yellow one or a red one. The red ones are the ones I usually check out. It'll say something like somebody else is in the screen, or it'll say that you were talking to somebody. With some people talk to themselves, and that's fine. And or it'll say that somebody picked up their cell phone, though it'll recognize a cell phone. Sometimes it will, the exams are timed, yes. Usually when it tells me somebody picked up a cell phone, it's your calculator. And so I see thumbnails. It gives me thumbnails of all the alerts that it does. And if I'm concerned about it, I'll click on the thumbnail and play a little bit of a video. So it's actually a pretty good program. It normally doesn't alert like for anything like looking down at your notes, but every once in a while it will. It'll say that it can't see your face, but don't worry about it. I'll just click on the things that look like it's weird. I've had one or two times where I've had to like contact a student. Then it turned out to be nothing. But if I see anything really strange, I'll just contact you. Yes, you can use your calculator. Yes. You
Okay, thank you.
Yes. Yes, you will be sending me a picture of your work. Yes, 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 you will. And we'll go over all of that when we get close to the test. I'll explain how all that's done. But yeah, you're going to show your work on a piece of paper and send it in to me. So yes. All right. That was a great question. Good job. Okay, moving on. Okay. Oh, see, it tells you now. You want to take the test at the testing center? The problem with taking the test as a testing center is it's not printed and you need a webcam. I don't think they have a webcam. We can talk about that later if that's something that you need to do, Jackie. We can talk about that later. But generally, they don't have webcams there, so things are kind of weird, but we'll talk about that later. All
They
right.
have webcams that they let you use from the library. You can check one out with your
Oh,
student ID.
and I know that the computer labs have the webcams and the Respondus on them. So you can take it in the computer labs if you wanted to do that. All of the campuses have those. But thank you. That was good information. Okay, so I meant to not have these on here. Sorry about that. So gender is nominal because gender it doesn't have order. It doesn't matter. Temperature is interval because the zero does not mean an absence of quantity. So you can have 0 degrees, it's just cold. the number of days that you studied during the week, that's ratio, because 0 is means absence of quantity. And letter grades are ordinal because order matters. I love that it's ordinal. See, to me, that right there is the best thing. I'm glad they didn't name it something really weird that didn't help. That's the only one that helps, but you know. All right, questions about nominal interval ratio, the levels of measurement? Okay. I promise you the next few classes are going to be much more interesting than all of this vocabulary. I love it that y'all are sticking it out. Okay. We're at section 2.1. If you keep track of that sort of thing, we are done with chapter 1. You have all of the information you need to do the first homework assignment, the one that is due Thursday for attendance purposes. You have everything you need for that assignment. So just letting you know, so if you keep track of that sort of thing, we're now on section 2.1. As a reminder, qualitative categorical data is a category. It is usually it's either words or numbers that we don't do math with. So this is the new thing right here. A frequency distribution is a really fancy word that just is a list of the categorical data and how many times it occurs. So basically, if I was counting all of the pets in our class, I would say like dogs, there's 12 dogs owned in our class. Cats, there were 15 cats. Birds, there's 2 birds. So it was just basically, it's a list of what the variable is and how many times it occurs. That's what a frequency distribution is. Okay. So when we collect data, before we organize it, it is called raw data. So when it's not organized, when it's just a big list of mess as you collect it, it is raw data. So for example, if I had a bag of M&Ms and I just was pulling them out of the bag and wrote down red, blue, yellow, blue, brown, that's raw data. Just listing all of the things out, completely disorganized, raw data. After we organize it, it is no longer raw. After we've cooked it into some tables or graphs or things like that, then it is no longer raw. It is organized data. So there we go. No, I never say organized data. I just say raw data or just data. So our next slide is going to have colors of M&Ms. So basically I took M&Ms out of a bag and I just wrote down the colors. Just wrote them all down. And then I'm going to create a frequency distribution. So I know it shows we have 13 slides left, but they go really fast. So we're almost done. So here's all my M&Ms. Just pulled them out of a bag. This is the raw data. On your lab on Thursday, you're going to be required to put raw data on your Excel spreadsheet. And this is kind of how it's going to look. You'll put it in a big list, but basically it's just going to look like this. So what I did was I just tallied them up as I counted them. I just tallied them up. So you don't have to show the tally marks if you're doing a table like this. This was just easier to count this way. So I have 12 browns, there were 10 yellows, 9 reds, et cetera, et cetera. This is just, the frequency is just how frequently does it show up? How many times did it show up in my bag of M&Ms? And then their color. This is just a frequency table. Super, super simple. So relative frequency, this is the only math we're really doing today is relative frequency. So relative frequency is how many times does it show up, this number show up, or this, like how many times do brown M&Ms show up over how many total M&Ms do I have? So you're taking the number of that variable and dividing it by the total number of individuals or number of items there are. So that's what you're doing with, I don't know what's going on here. Just trying to pull out my calculator so I can use it. I'm going to need it in a minute. Okay, there we go. All right, so a relative frequency distribution is a table where instead of having the frequency or the actual count of things, you're going to have the relative frequency of each one. So I'm going to show you how to do that. Okay, so here I have 45 total M&Ms. So I took the 12 brown M&Ms and divided it by 45. So this right here is the relative frequency. I have 10 yellow M&Ms, so I did 10 divided by 45, and I got 0.2222. Same thing here. I just went down the list and did this math, put it in my calculator, and found each of these relative frequencies. The thing that's nice about relative frequencies, and the reason that we use them a lot, is if I had another bag of M&Ms and that bag of M&Ms had 58 pieces in it, the 12 isn't going to be meaningful for comparing the 12 browns versus the 18 in the other bag. It doesn't mean anything. But if I'm comparing the relative frequencies, it's going to be more meaningful comparing those. So that's why we bring it to the relative frequencies, because I can see 26.67 of my M&Ms were brown. So it makes it a little bit easier for comparing things. Questions? Right. Okay, so bar graphs. You've seen so many hundreds of thousands of millions of bar graphs. So we use bar graphs for categorical data a lot, mostly when it's categorical, or if it's a lot of times for discrete data, but if it's quantitative. The bar graphs are super useful. You see them all the time. These are a couple little things that we do here. So we're going to label your horizontal and vertical axis. So your vertical axis, this will be frequency. This will be frequency or relative frequency. And then this is going to be whatever your variable is. This is where you're going to label your variable. And then you have your rectangles that are your bars. They are all going to have equal width. And then the height represents the frequency of whatever it is you're counting. So super basic. You're not going to have to draw a bar graph by hand, but I think you're mostly just going to be reading bar graphs. I don't think that there's going to be much drawing of bar graphs. You will be doing one in Excel though. That's going to be part of your lab, and it's going to be beautiful. I'm excited. All right. Okay, so we're going to use the M&Ms to construct a bar graph and a frequency bar graph and a relative frequency bar graph. All right, there's a blank slide. So here's our frequency table. So my bar for this one is going to go up to 12. It's going to go up to 10, et cetera, et cetera. Here's my lovely frequency bar graph. So important things to remember. Your graph is always going to have a title. Always. Always, always. Always a title on your bar graph. It can be something super basic. It doesn't need to be fancy. You need to have axis titles, axis labels. So you got to tell me what those axes are. You got to tell me if it's frequency. Is it relative frequency? Is it something else? And tell me what your variable represents. And then then we have our categories or whatever right here. These are the labels that need to be there. See, this is beautiful. Lovely little bar graph. And so it tells me how many of each thing showed up, and it's just nice. All right, let's take a look at the relative frequency bar graph. Here's my relative frequency table that I created. This looks pretty much identical to the other one, just instead of the frequency over here, it is now relative frequency. This would be, if I was comparing two different bags of M&Ms, I could have, with it being relative frequency, I could have another bar next to it for the second bag of M&Ms, and you'd be able to compare them, and it would be really nice and easy to read. That's one of the reasons we like relative frequency. I tend to use it more than actual frequency. Any questions on bar graphs?
Is relative frequency, do you tend to try to think of it in a percentage form, or do you get used to reading the decimals?
I usually jump to percents, and I don't care either way with you guys or whatever you choose to do. I generally jump to percents just because in my brain it makes more sense. So we write them as decimals like this, but if you think of it as a percent, that's exactly what it is. So go for it. Think my open math jumps back and forth, so be really careful. My open math and at the way that they want you to enter it. Now, if you were entering it as a decimal and it said percent and you were kind of messing up, if you send me a message, if you run out of tries and you send me a message and say what's going on here, I'll tell you, hey, this is supposed to be a percent. I might give you the points back or just you can just redo it or whatever, but just try to pay attention to how it wants it. But I don't care either way. If you are on a test and you said 53% instead of 0.53, even though it would mark you as wrong, I'd fix it. There, I recommend the TI-84. It looks like this. Hold on a second here. The in-person one looks like this. You can check them out at the library. I believe it's $20 for the entire term. If you're not taking any math classes after this, 20 bucks. Uh-oh. Got it. The 20 bucks will, oh, it's 10? Okay, thank you. So it's $10. So $10 at the RCC library. You can check out a library or a calculator for the entire term. So yeah, that's
Do you have
beautiful.
a link to that online one?
I had to pay for this. But it was only like 20 bucks for a whole year, but you can't use it during a test. That's the problem. You can't use the online one for the test. I mean, if you want to pay the 20 bucks for a year, you're more than welcome to, but not being able to use it for a test could be a deal breaker. I just like having this one. And there's one person in this class, I can't tell you guys who, but one of them is in my high school class at the high school. You can borrow one from me, check one out, talk to me tomorrow. All right. Okay, go back. Right
Is
here.
my open math something we're supposed to, I don't see it anywhere on the content for the weeks or anything.
When you click on, let me jump. This is a good question. I'm gonna jump into Blackboard. I don't know why Blackboard is such a pain. Okay, so let me go to our class. Have you guys noticed that that red thing comes up when you try, if you left Blackboard and then you try to come back? Okay, so if I go into the assignment, so take a look here. I'm going to click on Chapter 1 homework. It's going to send me to My Open Math. My Open Math is embedded.
Oh, okay, because I didn't see, like I was looking at the URL and I was looking everywhere for somewhere that said my open math.
Yeah,
Okay,
it
that
is
makes sense.
embedded. But
Okay.
so since we're here, if you click message instructor, like let's say for some reason this one was really you were really struggling with this problem. If you click on message instructor, it opens it up in My Open Math. And if you send me a message here, I'm going to respond to you in Blackboard. I'm going to actually copy your question and paste it into the Blackboard messages and respond to you in Blackboard. So don't worry about it sending me the message on the other platform. I will get to it and I will respond to you in Blackboard. So you don't have to worry about that. But everything that you're uploading ends up uploading directly into My Open Math. And so yeah, it's all right there. Don't even worry about it. So yeah, okay. Back here. We're almost done. I'm literally on slide 33. So see those last like 10 slides went so fast. All right, next. This is probably the first, last, and only time I will ever talk about a Pareto chart. The only reason I talk about it is because it is in the standards and I have to teach it to you. I will never ever test you on Pareto charts. I don't think there's any homework assignments on Pareto charts, but you have to be exposed to it. So here you go. The only thing different between a Pareto chart and any other bar graph is that it is drawn in decreasing order of frequency. So the highest frequency is on the left and then it goes down from there. So this right here is a Pareto chart. My tallest is on the left and then it steps down. So as opposed to this one where blue is lower than green, and so it goes down and then back up. Pareto chart orders them like this. That is the first, last, and only time I will ever say Pareto chart. So there you go. Okay. Any questions before I talk about the lab for Thursday? Anybody have any questions about what we've covered today, or any other stuff that you are cool asking about on camera or on sound anyway, recorded? Okay.
Are the tests accumulative?
No, they're not. I mean, everything kind of builds on itself a little bit, so you're going to have to rely on prior knowledge, but they're not cumulative. No, it's going to be over. Like, I think the first one is chapters 1 through 4, and there's not a final test. It's a final project.
Okay.
That was a good question. Thank you.
As far as the notes go, oh, is someone else talking?
You're good.
Okay, as far as the notes go, you said to print out the PowerPoint, but can you just take notes in like a regular notebook or okay.
I just recommend the PowerPoint because the PowerPoint has all the graphs and everything, and sometimes it's a little bit easier to take notes, but absolutely, yeah, take notes on whatever you want.
Okay, thank you.
Yeah, take notes on your sister's pregnant belly or something. I don't care. I'm kidding. All right, so notice in the chat the conversation about the Discord server. I think that's an amazing job. I love that that's a thing. Thank you so much for setting that up. I don't know much about Discord, but just you do you. So, and I think, didn't you put that in the forums also, the link to that? So yeah, I think that there's a link in the forum. So yes, definitely join the Discord server, help each other out. And the forums are a really great place to ask questions of the whole class. But yes, absolutely. Okay, now before I'm going to go back to that blank page because I'm going to talk about the lab. So for the lab, you're going to need 3 different data sets. Now, I think the lab itself still says that you need 50 data values. You do not. 20 data values, 20 data values of each type of the data below. So I'm going to give you 3 different types of data that you need to collect, and you need 20 data values of each type. Okay, first, I need categorical data. So you need 20 data values of categorical data. I'm not asking you to go ask all of your friends a whole bunch of stuff because there's going to be several labs. There's 5 different labs plus a final project. If you don't want to annoy your friends by asking them new questions for every lab and everything, and you want to save it to the final project, I recommend just using Google for your data, or categorical. You can sit on your front porch and look at the first 20 cars that go by and write down the color of the car. You can stand in front of your closet and look at 20 shirts and what color they are. You can look at the color of the the books on your bookshelf. It could be some super basic stuff. I'm not, look at 20 cans of food in your cupboard and write down soup, vegetables, things like that. I don't care. Just pick 20 things in categorical data. Number 2, continuous data. You need 20 data values of continuous data. You can ask, I don't know who's going to tell you your weight, but you can ask 20 people your weight. You could look at, a really great way to do this is go on, it's still football season. So pick your favorite football team and write down the height of 20 football players on your favorite team. Now, I'm going to tell you, if you do height, do not write it down in feet and inches. Convert it to inches. Just trust me, convert it to inches. But that's a good one, or the weight of 20 football players. You can do temperature on the last 20 days of 2024. I don't care. So find some continuous data. Look at rainfall, average rainfall for the last 20 years, whatever. So that's continuous data, 20 data values. Number 3, you need something discrete. Remember, discrete variables are quantitative, so they're numbers you can do math with, but they're countable. So look at for some reason my brain just shut down. How many kids 20 of your friends have? Look at go for a walk and look at 20 houses and how many windows are visible from the street. How many cars are in each driveway as you're going on your little walk? It can be anything, but 20 data values of something discrete. Remember, that is something that is a number that is countable, so something that's not continuous. All right, questions about the lab. I'll tell you how to do it on Thursdays, but questions about what you're going to need for the lab.
If we want to get a head start on it, is it in Blackboard somewhere with directions?
Yes, if you scroll down to the very bottom of week 1, there's a video instructions of the lab, and it is exactly what I'm going to go through with you on Thursday. So video
Thank you.
yes, it is the very bottom. Let me see if I can get there since I'm already in there. So it's right down here, the very bottom, instructions for lab 1. Just click on that and there's a video. There's minimal instruction, the lab itself. So let me even show you. If we go into the lab, so go start. The lab document is right here. Remember, labs have to be done in Excel. There's a document at the bottom of the content page that will show you how to download Excel to your computer. You get it free through RCC. So, but there, I created a document that shows you how to do it. It says Microsoft Office free, something like that. Let me see if I can get to it. Anyway, it's down here, student email, free Microsoft Office. So I created a document right here that walks you through how to get free Microsoft Office. And it's a little small, but you can. And so it's, as long as you're an RCC student, you get it for free. And you can download just Excel if you want, or you can use all their products, and I prefer them. But anyway, so you have to use Excel. You can't use numbers. You can't use Google Sheets. It has to be Excel. Excel has some of the functions we're going to use in later labs are only available in Excel. So that's why we're using that. All right. That's all I've got for you. So any other questions that you want to ask while we are being recorded?
Are you saying we need to have these 20 data points before Thursday?
You don't have to. If you want to have them so you can work along with me when I show you how to do it, you can. The lab isn't due till Tuesday of next week, so just make sure you get it done before the end of the day, Tuesday next week. But I just wanted to give you the heads up so that if you wanted to start collecting them, you can. Google's your friend. Use Google if you want to for these data sets. Find something interesting or even not interesting, something super boring. I don't care. But man, you can like search shoes on Amazon and find the color of the first 20 shoes that show up. I don't care. I'm not asking you to have something you're super interested in. Save that for your final project. If you listen to music or radio while you're taking the test, as long as it's not too loud, yeah, I don't mind. So it's probably soothing. Technically, okay, I'm going to tell you. Technically, I'm supposed to say no. I know throughout my college career, I was told you can't listen to headphones, you can't have earbuds in. Most teachers don't allow that. I'm not supposed to allow that, but I'm not going to disqualify your test if you have a little bit of quiet music going on. So I just said this on recording. Hopefully nobody that's in charge of my job watches it. Like they're really going to fire me. They would just say, Melissa, don't tell them they can listen to music. Anyway, as long as it's not distracting, I'm probably not even going to really notice. I mean, people have screaming kids happening while they're taking the test, so doesn't that seem more distracting than music? I can't tell you how many times there's been kids running through the back and people trying to wrangle them. Try not to do that, but you know. All right. Anything else while we're being recorded? Okay. I'm going to stop the recording. If I can find the button to stop the recording. There it is.